Hey guys, this lesson is going to be on writing linear equations. And so by the end of this lesson, we should be comfortable writing linear equations from points, graphs, tables, and word problems. So it's going to be kind of a lengthy lesson, so we're going to dive right into it. So remember, when you're looking at a linear function, linear functions are functions that can be written in the form y equals mx plus b. That's slope-intercept form. And in that form, the m represents the slope, and the b represents the y-intercept. So the x and the y stay in there as variables. They can be changed out to be different things from a point. But the m is a number. It's going to represent your slope. The b is the y-intercept. It's going to represent the point where your x is 0, the point where that line crosses your y-axis. That's review. We know that kind of thing already. So if you're asked to write a linear equation, there are basically 3 scenarios you could be given and be able to write a linear equation from them. The easiest is if they give you a slope and a point. Nope, I'm sorry, not a point, a y-intercept. That's the easiest option. If they say, write the equation of a line with a slope of this and a y-intercept of this, boom. It's super, super simple to do that. You just put the slope in where the slope goes, the y-intercept where the y-intercept goes, and there's your equation. It's done. Now, sometimes they're not going to give you both of those. Sometimes they'll give you a slope and a point. So that's going to be a scenario where we're going to have to solve to find the y-intercept. And then we can put the slope in where the slope goes, the y-intercept where the y-intercept goes, and boom. But if they don't give you the y-intercept, you'll have to solve for it. And then sometimes they're just going to give you 2 points. So that means you're going to have to solve for both the slope and the y-intercept. So anytime you're asked to write an equation, you want to first find the slope and the y-intercept. Then you put the 2 pieces of information together into the y equals mx plus b equation. So we're going to approach all of these problems that we do today with searching for m, searching for b, putting those 2 pieces in place in the mx plus b equation. So let's look at this from a graph. Now we know on a graph, if we're asked to write an equation, we're going to need an m and a b, but we know to find the m on a graph, the slope on a graph, we look for 2 stop sign points. And so if you remember, a stop sign point is a point where the line crosses exactly where 2 grid lines intersect on the coordinate plane. So there are several stop sign points we could use on this. And I'm just going to start down here on the left side of my graph and go all the way up and show all the stop sign points. Now, we're only going to use 2 of them, but I want you to see all of them just so that you're familiar with where I'm getting these points from. So as I work my way up the line, the first stop sign point I see is this one. Oh, I wasn't exactly meaning for that to look like that, but that's going to be okay. That kind of works good. And then the next one, I see if I keep going, I see another stop sign right here. I see another stop sign right here. Another one right here. And then really this point up here at the very top of that arrow would be considered a stop sign. And again, if you're confused about why I'm calling them stop sign points, I'm looking for a place along that line where the line touches exactly where 2 grid lines intersect, like a 4-way stop. But it has to be where the line is, not way down here where I just drew that. So these are all the points that I could use, and really technically this would also be one right here. So there are really 6 points along the line, the graph of the line I'm given right here, that I could use to find my slope. The easiest thing to do is to pick 2 that are close together. It does not matter which 2 you choose, but the 2 that are closest together is usually your best bet because it keeps you from having to simplify as much. So I'm just going to use these 2 at the top up here because it's going to be easy for you to see what I'm drawing to do this. But again, it does not matter which 2 you use as long as you follow this same format here. So to go from this point right here to this one up here, I'm going to rise and then I'm going to run. And so I create that triangle with my rise and my run just so I can visually see how far up I had to go and how far over. And I keep using colors that are in the graph already, and I didn't really want to do that, so hold on. Let's go with green. Up and over. And so when I count how far up I went, I'm going to count steps, not the point I start on, but steps. So it goes 1, 2, 3. And then to see how far I go over, that's the run part of it. Again, I'm not going to count where I start, but I'm going to count steps. 1, 2. So when I think about that in terms of the slope of this line, I do the rise divided by the run, 3 divided by 2, and I get a slope of 3 over 2. Or you could simplify that to 1.5. Either one is okay. Now, the B is easier to find on a graph because the B is just the place where it crosses your y-axis. So if it crosses at a nice pretty whole number, we can just find that whole number and be done. And this one does do that. This one crosses right here at 2. So the B is 2. And so once I know an M and a B, I put those things together into my equation. 1.5x, because the M goes with the x, plus 2, because the B goes by itself. So the M is always the one that gets the variable, the x. The B is the one that gets the, or doesn't have a variable. So make sure you don't put an x with the wrong one, because we'd be incorrect with that. All right, let's look at another one. Same thing, we're going to write the equation of this line. So we're going to find the M and the B. This one gives us all the stop signs, so that makes it even easier because we don't even have to find the stop sign points. So I'm going to look at this, and I'm going to find 2 of those points, and I'm going to rise and run to get from one to the other. I'm just going to use these 2 on the end right here, rise and run. Now, here's what you want to be careful of. It looks like I go up 1 over 1, but I don't, because this graph is counting not by ones, but counting by 5s along the y-axis. See how it goes from 5 to 10 to 15 to 20. So every time I go up a line, I go up 5. And then along the x-axis, every time I go over to the right a line, I go over 10. So I rise 5, I run 10. So my slope would be 5 over 10. But that reduces to a half. So I'm going to leave it as a half. Or if you like decimals, you can leave it as 0.5. Either one is okay. And then the B, again, is that place where it crosses the y-axis. So if I'm looking at this, it's touching the y-axis right there at that point. That point is 10. So my equation for this line, y equals 0.5x plus 10. Again, a lot of this should be review. We did some of this before. So this should be review for you for the most part. This part of it is anyway. All right, let's look at one from a table. So still, if we're asked to write an equation from a table, we still got to know an M and a B. Now, finding slope from a table is a little bit different than finding it from a graph. We don't rise and run to find it. Although you could plot 2 of these points and rise and run between them if you wanted to. But then you have to create a graph and all that, or go in Desmos and type the points in. And there's an easier option. So if you remember when we looked at tables, we could find our rate of change by looking from one point to the next to see how it changed along the x and along the y. So like to go from 3 to 4, I would increase by 1. To go from 5 to 6, again, I would increase by 1. And so I divide what's on the bottom of this by what's up top. So for this, it doesn't really matter because 1 divided by 1 is still 1. And I get a slope of 1. Now, you might say, well, it goes by 1 right there, but over here it goes by 2. It does. This goes up by 2, and so does this. 2 divided by 2 still gives you 1. So you still get the same slope, doesn't matter which 2 points you use. I could even use these, like I could start over here at 5 and go all the way to 10 and say I increased by 5 here. But if I go from 3 to 8, I'm also increasing by 5. And 5 divided by 5 is still 1. So it does not matter which 2 you use. You're still going to get the same slope if it's linear. Now, the B in a table is a little bit trickier to find if the table doesn't give it to you. Now, sometimes the table will show it to you, sometimes it won't. Remember, the B is the y-intercept. And if you're thinking about a coordinate plane, and you think about where something crosses the y-axis, that point is always 0, comma, a number, because it's on the axis. So on a table, we're looking for the point where the x is 0 to be able to know what our B is. Now, this table, the smallest x value I have is 3. So I don't know where x is 0, but I could extend this table to find it. So if I'm at 3, I could back it up to 2, to 1, to 0. And because I know my rate of change is 1, increasing by 1 every time, I can just decrease by 1 to move back. So if I was at 5 when my x was at 3, I'll be at 4 when my x is 2. I'll be at 3 when my x is 1. I'll be at 2 when my x is 0. This is my y-intercept. So my equation is y equals 1x plus 2. Now, you're probably, if you were looking at this in a multiple choice setting, you would not be given the 1 in front of that x. So it's going to look like x plus 2 is the simplest form of that. All right. Do another one with a table here. So here I've got x's and y's. Again, I've got to write an equation, so I'm going to identify my m and my b. M we can find by looking at how the table is changing. Here the x increases by 2 to go from 0 to 2. To go from 4 to 6, we also increase by 2. And I'll divide that. The bottom one divided by the top one gives me a slope of 1. Now again, the b value in a table is the point where x is 0. Luckily, this one shows it to me right here, 0, 4. So my b value is 4, and my equation is y equals 1x, or just x plus 4. All right, moving on. All right, so now we're going to take this a step further and start looking at it with just 2 points. Now, remember, when you're finding the equation of a line, you always have to find the m and the b. And we want to start by finding our slope. So slope is found when you have points using that slope formula. So the slope formula says y minus y, and I'll write that up here in case you've forgotten it. We really call it y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that just means the second y minus the first one over the second x minus the first x. So if I look at these points here, I'm going to subtract my y's on top. So the second y is 5. The first y is 1. The second x is 0. The first x is negative 2. And so I'll either put that in my calculator, type that in Desmos, simplify the top and bottom, and then divide it. Either way, any of those ways you choose to do, you should still come up with the same slope. But if I do 4 over 2, which is what that comes out to be, I get a slope of 2. So my m is going to be 2. My b value, now if they don't tell you the b, you're going to have to solve for b. If they do tell you the b, then you can just pull the value you need out of that point. Remember, when you're looking at a set of points or a table and you're looking for b, you're looking for the point where x is equal to 0. This one actually gives me that point. This point right here at 0, 5 is my y-intercept. And the only reason I know that it is because I have an x value of 0. So if they tell you the y-intercept, you don't have to solve for it. We know the b is 5 because that point is a y-intercept. So I have my m, I have my b. My equation is y equals 2x plus 5. All right, let's look at another one. Same deal. We're writing the equation of a line that passes through 2 points. So m and b. Again, I want to find m first. I always start by finding your m. So since I have points, I'm going to use the formula. Y's are on top, x's are on the bottom. So negative 3 minus 4. And then on the bottom, 4 minus negative 2. And I end up with negative 7 over 6. That does not reduce, and that comes out to be kind of a weird-looking decimal. So we're going to leave it like that, negative 7 over 6. Now, this time, if you look at our points, neither of our points has a 0 in the x spot. We've got one with a negative 2. Got one with a 4. So since neither of them has a 0 there, we don't automatically know the b like we did on the last question. So we're going to have to solve for b. And this gets a little bit tough. We've not done a lot of this. I showed you this the other day. But we've not done a whole lot with this. So I'm going to show you again how that works. If you have to solve for b, we take the original format of the equation, y equals mx plus b. We put in place of our m what we calculated when we got slope. So if my m was negative 7 over 6, that's what I'm putting in right there. Now, I'm looking for b, so it makes sense that my equation keeps the b. But the only way to solve an equation is to know everything except the variable you're looking for, which means I also have to know the x and the y. So I'm going to put in place of my variables an x and a y from one of these 2 points. It does not matter which point you use. You get the same answer either way. So I'm just going to use this first one. So in that point, remember the first number in a point is a x. The second number in a point is a y. So I'm going to put negative 2 in where the x goes. So because this says x here, I've got to put the negative 2 here because that's the x from my point. And then where the y goes, I'm going to put the y value in that point, which was 4. Then I'm going to solve this equation. So I'm going to multiply to start with the negative 7 over 6 times the negative 2 and get positive 14 over 6, which comes out to be 7 over 3. And you could use a calculator for that if you and fractions are not friends. This side is still 4. I'm just bringing that down. And so then to get b by itself, and I know you're used to seeing it where we try to get our letter to the left, but because b is already alone and already positive over here on the right side, the easiest thing to do is just to move the 7/3. So we subtract it because it was positive over here. And so our b is equal to 12 minus 7 is 5/5. Again, if you and fractions are not friends, you could do that in a calculator. So my b is 5 over 3. And so the equation, now that I've got both those pieces together, is y equals negative 7 over 6x plus 5 over 3. All right, let's go do another one. Let me see. Now here we got 2 points again. We're writing the equation of a line, so let's look at that again. Start by calculating your slope, and if you feel confident in it, go ahead and pause the video real quick, calculate it, and see if you get it right. If you're not confident you can do the slope yet, then you can watch me do it again. But if you think you can, try it, see what you get. All right, I'm going to put negative 17 and negative 5. Notice I still have subtraction here, because it's subtraction no matter what. That's the formula. So I'm going to subtract negative 17 minus negative 5. And then I'll do 3 minus negative 1. So I end up with negative 12 over 4, which comes out to be negative 3. Maybe you got that if you tried it on your own. So I get my slope is negative 3. Again, I don't have a point that is a y-intercept because neither of these starts with a 0. If this was a 0 in either one of them, we could use it, but it's not, so we can't. So since I can't, I'm going to use my formula or my equation to solve. So I'm going to take y equals mx plus b. Where m is, I'm going to put negative 3. And where the x and the y are, I'm going to put an x and a y from one of those 2 points. I'm just going to use negative 1 and negative 5. So I use these two. Again, I put the x as negative 1 because the negative 1 is in the x position of the coordinate. So negative 1 has to go here where the x is. The negative 5 that's in the y position goes here where the y is. That's a common mistake for people to mess up. So I just want to make sure we're clear on how that works. And then I multiply. Negative 3 times negative 1 is positive 3. Bring down my negative 5. And then to get b by itself, I just subtract the 3. So b is negative 8. And so my equation, negative 3x minus 8. All right. These up. Let me see how many. Try this one. Take a minute, pause this video, and try this one to see if you can get the correct m and the correct b to create your equation. Then unpause it and see if you are correct. If you have not paused the video, pause the video. Thank you. All right, take a look at what I ended up with. I calculated my slope by putting in 3 minus 7 on top and 3 minus -1 on the bottom. And when I calculated that, I came out with a slope at -1. I put that in for m, and I used my 0.33. You could also use this one, it does not matter. But I used 3,3 to put that in over here for x and y. And then I solved that by multiplying -1 times 3 to get -3, and then adding that to both sides to get the -3 to cancel. And that gave me a b value of 6. And so I put that in place, -1x plus 6. You might also see that written as just -x plus 6. A negative x is understood to be a -1, so you could see that either way. All right, hopefully you got that correct. So that's situations where they give you, I just want to make more of these I have, points. Now they might also give you a situation like this, where they give you a point and a slope. So I have a point and a slope this time, which means I have one step already accomplished for me. I already know the m is 2. But I'm going to have to use that and calculate the b, unless they give us the b as well, but they don't in this situation. So to calculate b, all I'm worried about now is the mx plus b part of it, where I sub something in for everything except the b. So you should be able to put in 2 for m, because they told us our slope was 2. And then for x and y, I'm going to put in the values from the point. Now, it happens to be 2 in both situations here, so everything's 2s. It's a lot of 2s, right? And then I calculate. So 2 times 2 is 4 plus b. Bring down my 2. Subtract the 4 to cancel it. And I find that b is -2. 2 minus 4 is -2. So my equation, 2x minus 2. All right, what about this one? They tell us the slope, -1/2. And they give us this point. Now, we could solve for b using that point by plugging this in for m, this in for x and y and solving. But maybe you noticed in this point that the x value is already 0. That means they already tell us the b. It's 8. This point is a y-intercept. And I know that because it has an x value of 0. So that means I can just write this equation. -1/2 x plus 8. All right, take a minute. Try this one and the one on the next slide. Actually, hang on. I lied. It's just this one. Pause the video, try this one. See if you can come up with a y = mx plus b equation that passes through these 2 points. Find your m, find your b, put the equation together. So pause the video, try that, and then come back and see if you were correct. All right, take a look at what you got compared with what I got. I started out by calculating my slope and I did 4 minus -2 and 8 minus 5. And I got a slope of +2. You end up with 6/3, which comes out to be 2. So I put that in for m. Then I calculated the value for b using the 0.84. Now, you might have used 2 and 5, and that's okay if you did. You still come up with the same answer either way. So I worked that out, and I multiplied that and got 16, subtracted 16 off both sides, and got -12 as my b. So y equals 2x minus 12 is the solution for the equation for that one. So that's the end of the first part of this lesson. So I'm going to go ahead and publish this video, and then I'm going to make a part 2 with the word problem section of this. So if you finish this part of your notes, go ahead and save that, and then you can watch the next part of the notes if you were out that next day to get the part on word problems. All right, y'all have a beautiful day.